Welcome back. So we're going to now continue on section 5, talking about solving exponential logarithmic equations. So yesterday you saw we used logs to undo exponents. Well, now we're going to use exponents to undo logs. So the focus of today is logarithmic equations and how we can use exponents to undo them. So the goal here is we're going to rewrite these as exponential equations because those are going to be easier for us to solve. So when there's no base, well, remember that means it's base 10. Now let's use Mr. Loopy to go and rewrite this. So 10 to the second power equals that 4x minus 3. Well, 10 squared is just 100. So the really neat thing here is now I just have something linear to solve. Once I transform this, now it's going to be super simple for me to finish solving. All I have to do is add the 3 over and divide by 4. And 103 divided by 4 gives me 25.75. So as long as you remember that that's a step you have to take, I don't think you'll have many issues being able to solve these. They're mainly really doable. So let's take a look at this one. Again, if there's no base written, remember that means it's 10. Mr. Loopy, 10 to the negative 1 equals 3 minus 2x. Well, 10 to the negative 1 is just a number. It's just 0.1. So 0.1, let's subtract that 3 off. So negative 2.9 equals negative 2x. And let's divide that by negative 2. So I get 1.45 equals x. So again, that's the really neat thing here. Once you transform these, you get something linear that you can very easily solve. Okay, now of course, you do have to take care of anything that's on the outside first. So in this instance, I need to divide that 2 off. Okay, now that I have that log by itself, now I can rewrite it. So 3 to the 4th power equals all of that. Well, 3 to the 4th power is just 81. So plus 1 to that, we get 82 equals 4x. 82 divided by 4 gives me 20.5. And that'll be all. This one, the first thing I need to take care of is that 1. So let's subtract that 1 off. Now that log is isolated, so let's do Mr. Loopy. 2 to the 6th power equals 5x minus 3. 2 to the 6th power is 64. So let's add 3 to that to get 67. Divide by 5. And we'll get 13.4 as our answer. All right, so again, actually, I don't think that this is that difficult. All it takes is rewriting it, use Mr. Loopy, and going from there. Now, of course, it's going to escalate from there a little bit, okay? Now, what I mean by that is when you have more than one logarithm showing, when you have more than one log, what that ends up meaning is you're going to have to use the properties to condense the log. So what I mean by that is here we have subtraction. Subtraction means I can rewrite this as a division problem. Okay, I can condense it together by dividing them instead. So that's going to be the key here. When you have multiple logs, you need to condense them. And now, and only now, I can use Mr. Loopy. 2 to the third equals all of that. So 8 equals all of that, and now let's solve. Well, because the whole thing is being divided by 5, let's take care of that first. So multiply the 5 over, subtract the 1, and now divide by 5. And 39 divided by 5 gives me 7.8. Right? So not too horrible. Just make sure that you know those condensing properties. Okay? That's going to be the key to doing well on these. What about here? Adding means that I can multiply. So I can condense this. 2x times x is 2x squared. Now, let's use Mr. Loopy. So 4 to the third equals 2x squared. So 64 equals 2x squared. Well, let's divide the 2. And now to undo a square, I need to square root. So the square root of 32, keeping with our tradition of 4 decimals in this chapter, 6569. Now, notice, why have I ignored the negative? Okay, because I hounded into your brain. Whenever you square root, you need plus or minus. So why am I ignoring it? Well, that goes back to the very first day of doing this. Back on the very first day, we said you can't take the log of a negative number. Well, if x were negative, that would mean that we would be taking the log of a negative number. So here, even when you're square rooting, you need to ignore a negative if you were if that would make the whole log end up being negative, because that's something we know we can't do. So here the answer would just be positive 5.65 or 6569. All right. Now this one, the two logs are on opposite sides. So while that's a little bit of a hiccup, you can just add that log over. So log of x minus 3 plus log x equals 1. So add it over, and now I can see I have my addition property. So to combine those logs, I need to multiply. X minus 3, quantity times x, would be x squared minus 3x. Okay, again, all I did is I multiplied the x times x minus 3, which implies distributing. Now I can rewrite this. So, Mr. Loopy, 10 to the 1 equals x squared minus 3x. 10 to the first is just 10, but I have something quadratic. So the only way to solve something quadratic is to get it set equal to 0. And now the fun comes in, because I get to factor this. So our factoring skills, still very necessary. All right. So that gives me my two solutions of x equals 5, x equals negative 2. Now, we do have to be very careful though, because notice right here, if I were to plug in that negative 2, I would have issues. So really my true solution is just the 5. Okay, so, and recall that's what we would call an extraneous solution. Okay, negative 2 is extraneous because while we get it as an answer, it doesn't work in the original context of the problem. All right. So, finally, let's do a word problem and then we'll be good for the day. So, The wind speed s in miles per hour near the center of a tornado is related to the distance d in miles the tornado travels by the equation s equals 93 log d plus 65. On March 18th, a tornado whose wind speed was about 280 miles per hour struck the Midwest. How far did the tornado travel? So this is a wind speed. So I'm going to plug that in for S. Oh, plus, sorry, make that look a little bit nicer for you. All right, so let's take that 280, subtract off the 65. So 215 equals 93 log D. Now, when you divide off the 93, because we're not done with the problem yet, I'm going to leave it as a fraction because I want to stay as exact as possible for as long as possible. Okay? So, as we talked about, now let's use Mr. Loopy. So 10 to that power equals D. So I need to take 10 to the 215 divided by 93rd power. Well, my calculator can do that for me. 10 to the 215 divided by 93rd power. It went about 205 miles. All right. So just to show you a nice application of where this can pop up in real life. All right, so thank you so much for joining me. So write your summary, please. Write down there. Reflect on what we talked about, the differences and commonalities between solving exponential equations, solving logarithmic equations, and then come back ready to do your practice work.